Right, so here we have a issue 6A board which needs to be refurbished and maybe repaired. I don't know, I have to check. Seems to be a new voltage regulator in, but we'll put in a Raycoma Trico Power DC-DC converter which stays cool. One upper RAM chip has been replaced. All the capacitors except for these three ones, I think, are still original, all the blue ones. I'm not entirely sure, but yeah, I think so. I can see that TR4 and 5 have been replaced somewhere in this lifetime of this ZX Spectrum. There's still a reset cable on. We'll put it on for now, leave it on for now. But the refurbishment will include removing the socket from the ULA chip. But I don't know yet if this board works. So let's power it on. But before doing that, let's check if this one has a modification yet, but it hasn't. So this one is still original antenna output. So we'll change that to Composite video. I just powered on the soldering setup, so some ventilators came on. But if I'm correct, the noise filters should handle that, and you shouldn't hear much about from that. I can see that this modulator sits in a bit at an angle, so let's fix that as well. You can see it here. And the reason I think is that when it was put in, the flap here wasn't moved over the edge of the board, keeping it distant from the board itself. So that's quite easy. It's the soldering iron is heated up. Let's put some new leaded solder on it and then push it in entirely. That's about it. The other side. And I like to cut these legs because these haven't been bent, so I like to remove part of them so they will not interfere in the case. Right. Okay. Now let's do the composite video mod. I have detected that indeed some displays, TVs or monitors with composite video input don't like the simple modification, but I still do the simple modification. Maybe I should move over to the more complex one in the future with a transistor or a capacitor. We'll see about that. But for testing now, we'll just move on with the simple, ordinary modification. But sometimes there is a DC offset voltage which causes problems with some displays picking up the signal, the composite video signal. So we'll get to the composite version or the capacitor version in the future. So this is the modification, and I will cut the 5 volt to the modulator. It doesn't need power anymore. And I will open a window to stay healthy and put on the extraction hood as well. Right. So the next thing is I like to remove the heatsink here, but we don't have to yet. And I have something new. You can see I have a power cable here and audio and video. And right next to me, I think, yeah, you can just see it. I have a display here. And you can see it doesn't, no, you can't. There's a problem with the voltages and more. We'll check it in a second. But I also have a button now, which will show you what I'm seeing here. Shoot, yeah, there it is. Almost, no. It doesn't pick up the signal, and that's most probably, yeah, there it is. You can see there's all kinds of problems with the video signal itself, indicating either the capacitors are bad or there's a low memory problem. This one feels a bit warm. Or still there's a problem here in the voltage circuit, and of course we can check it easily with the die card, which I forgot to pick. But I can do this now at my workstation here. So again, let's check the voltages. Don't need to see the video output now, but you can see there's no minus 5 volt, there's no plus 12 volts. So there's a lot of problems on this board. What I could do is measure the 5 volts to see if the regulator outputs correct 5 volt or that it's somehow problematic. Let's do a quick check because the LED on the die card doesn't show exactly if it's 5 volt or not. Can you see it? Yeah, you can see it. 4.9, so that's okay. But I will start with replacing the capacitors as I always do, and then we'll continue testing the board. So let's get to the work desk view only. We don't need the composite video signal now. And let's remove all these capacitors. Also the replaced ones, which are not axial, so let's just remove them and put in nice ones. Let's grab the capacitor assortment, all the designs. These are rubber feet, as you can see. These need to be cut in size. Okay, here we have all the types we need. Let's get out the mini boxes here so we have all the values we need for now. Can save some space. Right. I forgot to pre-solder the pins, the lags of the capacitors, which is always something which is good to do. So let's do that. So in about 5 minutes or so we can see if the board still has the same problem. Then we will replace the two transistors, power transistors. And we can do some measuring on the low memory chips. We can see if there's a static impedance that is too low before powering it on, because otherwise we may destroy more chips or more transistors, and some of those are costly. So you can find this die card, let's put it here, on Sinclair.shop or bytelight.com. It's in our web shop. Many people have bought one already. Let's check the numbers. Die card, like about 600 people have ordered one already. Either an assembled one or a DIY kit. It's not the most difficult piece of hardware to build yourself if you like doing that, and if you're into repairing ZX Spectrums, you probably have a soldering iron and more multimeter, and so let's see if we can get these out without cutting them. This one doesn't want to. It's very windy today, so I think I have to close another window here in a second. Okay, I want to remove that heatsink because it's in the way. My hand is constantly bumping it. And we can also already replace the regulator if you want to, so let's just do that. I will put it back later for the looks, and let's replace this one. Although it's a new one, I want to keep the machine as cool as possible. I can see this is a new type because this one is a model from the last years. like 5 or 10 years. So I could keep it, but these are not the most expensive parts. So, alright, let's open up the holes for the parts. I think it's easier from this side. I have a desolder station, is at the 915, like many people have, but mine is not the best. I might do some modifications to it. I watched some videos recently with some relatively easy changes, but still the gun needs a lot of time to heat up, and it also needs a lot of time to liquefy all the pads you're touching. So this is so much faster what I'm doing now, so I like just to use this Japanese one. And I printed a handle for it. As you can see, this is rubber, so it's really easy to hold compared to an unmodified one. I've been looking for a Hecko desolder station, but those are start from like 600 euro or something. So that's quite a change compared to the ZT915, which is less than 100 euro. So I'm not sure if it's worth the money yet, and I don't use desolder stations or tools like this one that often. So I'm not sure if it's worth the money. I think in the long term it will, but for now I'll leave it as it is. I will use it this way. Alright, so those are open. Power to here. I hope the recording is okay. Let me know if you think something can be improved. I think the setup is quite nice with the noise filter enabled. Otherwise, it's really loud. It is quite loud in here, but the noise filter does a good job of removing most of the noise and still remain my voice as it is. Okay, so this LSO4 chip for the clock signal, I think, has been socketed as well. So someone has done some modification. So the PCF 1306 chip has been socketed, and this buffer chip has been socketed. I don't know why. So I think someone has tried to fix it. This machine, maybe he or she did in the past, but I can't tell if someone tried and didn't succeed, or that this is just some new problems with this machine. We'll see. And anyway, this needs to be done. Right, I think we're almost there. Most of the holes are open and cleaned. If you have any question, let me know. If you want to order something, you can go to zspectrum.shop or bytelight.com. Let's do a slightly cleaning of the pads because it just looks better. I want to make the board look as factory as possible. So a bit cleaning will do a nice job. Right. I have loads of repairs to do, as you people know, so I need to speed it up a bit. Hence I don't do live streams now, and I tend to do recordings. I have to do a lot more, put them on the YouTube. Right, looks a lot better, if I may say so. So this is what came off the board. Sorry guys, you have to make place for your new family. And now I've got out those boxes, but it's easier to just put this one underneath it, because this has all the capacitor maps on it. So I'm using this one here, which is for the 6A, as you can see. So let's put these back. I like to do it this way because sometimes it's easier to just get them out, you know. Not always, but often. I think many people can almost dream which values are going where, but not always, because every board issue has some specific capacitor values and orientation. So keep in mind that you need to check if the capacitors are aimed in the correct orientation. And on issue 2 boards, there is a orientation noted on the board, so there's a plus symbol, which isn't correct. So keep that in mind. If you put in the capacitor that way, then you could have a blunt capacitor sooner or later. But on the issue 3 and up, it's printed correctly, so you can just look at plus here, plus there. It's correct. So let's check 6A. We need a 22 on the bottom here. And this one should be a issue 6. Let me check. Issue 6. 6A. It's a 1 microfarad. So nowadays I don't even bother to check what's on the original values, the original capacitors. I just know that this map works. That's been proven by using it a lot. And of course, if you have a factory modded board, you have to keep a close eye on the original values, but not with the standard boards like this one. There wasn't any capacitor which shouldn't be there or something. All right, I think we're complete. Let's solder them in nicely, so they will still look as if they belong here. And often I make bridges between tracks on the board, so it's always good to check after you've soldered in the capacitors if nothing is shorting out. Never assume it's okay, just check it. So we'll do that in a second. Also, some blobs may still be on the board from desoldering the components, so put it upside down for a second or two. Give it some loving taps. And let the baby burp out his burp. Alright. So those are in. Oh. Nothing's really falling off, so should be okay. We got some lags. Oh. So I will do a check for resistance on the voltage pins of the 4116 chips. I will compare it to another board. But I also always want to make sure the parts are in properly, nicely, so it all looks nice as well as it works. Right. So, and this hasn't been soldered very nicely, so I will get this chip out if it works, and we'll solder it in. I will try to find the exact type, because these ones differ slightly. It's the same model, but it's doesn't have the same print on it, so maybe I can find the one that suits it better. Alright, so let's grab, this is very dirty now, but we'll clean up later. Let's grab a multimeter and a board we can compare it to. This might have different chips. No, this also has STC chips, which is okay. And let's do some quick measurements, but before that I have to check the schematic. Just a second. Alright, so on the issue 6A, just to check it, you can see that the 12 volt line is on pin 8, -5 is on pin 1, ground is on pin 16, and 5 volt is on pin 9. So those two are quite standard, but the other two voltages need to be checked as well, or the impedance at least. So let me check. One, 8, 9, and 16. So we'll just move it here or somewhere else where it will remain easily. Let me check if I can put this on. Yeah, we can. So I should write it down, because I've checked this before many times, but I'm a bit lazy, you know. So we can just write down the values. So pin 1, 1, 8, 9, and 16. We need the values, the voltages. We'll put this here. This is a known working board. Let me check. This is the -5 volts, which says 44K. Then we have pin 8, which is, what did I say, plus 12 volts, which is 2.5 kilo ohm. Then we have ground, which we don't have to measure, obviously, and then we have to take pin 16 and no, pin 9, sorry. Pin 9 is the 5 volts, I was mistaken. So this is ground, and this is 5 volts. And that says 2.0K. Right, well, let's compare that to the board we're working on. Alright. Let me check. So the first one is pin 1 was 44K, the other one. This is quite a bit lower, so this is only 4K. That's minus 5 volts and should be higher, so that's a question. Then we have the 12 volt line, which should be 2.5K, which is the same. And we have the 5 volt line, which should be about 2K. And this one is higher, so it should be okay. So I'm doubting a bit if the minus 5 volt is okay. Do a quick power on and see if anything changed after we swap the capacitors. And then we'll check the TR4 and 5. Most probably those are dead, but we'll see. Okay, we'll just power it on. Oh, don't have. Oh, of course, we don't have 5 volts at the moment because there's no 5 volt regulator. Sorry. Let's do that. Of course, I can do more measurements before doing anything else, but I just like to speed it up a bit. The only thing I don't like to do is blow up more transistors, voltage transistors. Oh, come on. We'll clean the bottom pads later. Just cut them a bit now, because these are quite long as well. Alright. Okay, let's do a quick test again. See if we get anything else. No, still no minus 5 volt and no 12 volt. And I can see some other problems as well. So the first thing we're going to do is check out this ULA chip, if this is working. And I should check the PCF1306 chip as well, but I don't have a board to go into now. But just want to check the ULA chip, and I know this board needs a new ULA socket, but we'll do that later. So let's see on a working board if this ULA chip is okay, because it's making odd sounds, but of course it can be the power circuit or something else, or maybe the Z80 chip or something. I will power on the display as well here, and this one also. It takes a bit of time. Okay, so this ULA chip seems to be working. There's nothing wrong. The picture is a bit wobbly, but it's because the quite cheap composite to HDMI converter I'm using. So don't worry about it. But this ULA chip is okay. Of course, we need to test it more thoroughly before soldering it into the board, but that's for later. I want to do tests like audio output, tape input, and more of that. Not now. Alright, so there could be a couple of things wrong with this board, but first let's get the power working. We don't need a ULA chip to check the power, so we'll keep it out for now. Just need to put in some new transistors. And before doing that, I want to check that minus 5 volts line again, because the resistance was quite low and it could mean it will blow up in any second. Though minus 5 volt is easier to get to compared to the minus 12 volts. But we'll check the circuit in a second. I always clean up in between jobs, but it's getting quite dirty now again, so I have to do that later. Right. Let's grab that magical cabinet. 653 TR4. And before doing this again, we'll measure the resistance on the -5 volt line. And 753. Oh, I hate these bags. These are the cheap white ones. I also have green ones, which are a lot better. But it's too small, I think. Will it fit? Ah, it will fit. Alright. 753. Right. Okay, so we changed that, but I want to check the schematic for the details on the 5 volt line before continuing. Here we have it, so let's do the screen cap again. By the way, I'm using a Stream Deck nowadays. We'll show it later on, but which is easy with the buttons and so. So on the 5 volt line here, sorry, -5 volt line, which is generated here, but it says 5 volts, but it's -5 volts. It's a bug in the schematic. There's a diode here, a Xena diode, this one, so we can check if that still works correctly. But as you can see, it's based on the -12 volts here. So if the -12 volt works, then the -5 volt should work as well. Though there can be a problem on the lower RAM chips, and I suspect that one of the lower RAM chips is failing. So we can do several things. What could be the best to do here? Maybe cut the -5 volt going towards the lower RAM chips and see if that makes any change. Alright, so I really hope the recording is okay. I did some changes to the setup, so I still hope it works fine. So what we're going to do is, let me check. Yes, so -5 volt is the pin 1. Oh, I see a burnt component, by the way, which probably is shorting, I guess. No, it's doing nothing. Let me check. It says 2K. This is R79, which should be, let me check, R79, 2K2. No, so the value is still okay, it's just a bit burnt, so that's not a problem. Could still be the diode, but I'm not certain about it. Let's put in a new 2K2 resistor. This one is burnt, you can see it from the camera. Where is... Did I measure the capacitance again? I don't think so, did I? After replacing the transistors. So let's do that quickly. I don't think I did already. It says 4K and the other board says 44K. So I wonder what it could be. I think the best thing to do, so probably one of the lower RAM chips is failing and they're pulling down the -5 volt. So we'll cut this one. Was it this one or was it the other one? And I forgot. This is not the correct one. I'm mistaken. It's one higher. So let's just fix that. It's this one. So we'll cut that track here and then measure on the left and on the right side, and we can see if one of the sides has a problem here. So first, let's see if we actually cut it. Yes, we did. And now we can measure again from 0 to here. This says 3.5 mega ohms, and this says 4K, 4 kilo ohms. So I think one of the lower end chips is failing. It's a bit hard to find the correct one. We can do it by either just powering it on and see if one gets hot, but of course that can blow up the transistors here, or we could test chips one by one, but we still need to put in the 2K2. Let's do that first. You can remove the lower RAM chip completely, which is 16 pins for each chip, until you find one that is failing, or you can cut the pins that on the voltage line that are causing the problem and hope you find the correct one quickly and resolder the pin that you cut. So that's a way of doing it. It's not the nicest way, but it's a quick way. But we can do a quick test. If you're quick enough, you can just power it off and there's nothing wrong. There will be nothing wrong with the transistors anymore. So let's do that. Let's do a quick test. No, they're failing, still failing. So quick test is done. There's still a problem. I don't think these are the transistors now. I think they're still okay. But we still have a problem on the -5 volts. So it's one of those chips. So what we're going to do is we're going to cut the pins 1. So this one is broken completely now, as you can see. So, sorry about that. Although it's just a package, but it chipped off the top of the chip, so that wasn't supposed to happen. I will replace the chip anyway, but I want to find the chip that is causing the lower impedance until we find. Oh wait, we don't have to power it on yet. We just can measure the impedance now. So it now says still 4K, which I think is too low. I should get another board to check it if it's 4K as well. But this I can repair what I'm doing now. So let's just continue measuring. See if we can find the chip that is causing the lower resistance. Still says 4K, so I'm doubting what it could be. I think we've got them cut all of them, so now let's see. It still says 4K, it's about 5K now. So I still think there is a problem with one of the chips. Let me check if all the connections from pin 1 have been completely cut. So maybe there's still a connection somewhere. Yeah, there is. So the second chip is still connecting. Oh man, these ones break so easily. I don't know why. So I chipped again chipped a bit off, which is odd. No reason for that, but anyway, let me check. Still says 5K. Yeah, there are still more connected. It's really hard to find the correct tool to cut these easily without chipping the chips. But anyway, we'll try again. We can of course just measure instead of look. These have been disconnected now. So this is the board, this is the chip, 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 yeah, chip, chip, and chip. So these have all been disconnected now. Let's now see what the impedance is on the -5 volt without connecting it to anything. Now it's in mega ohms. So okay, that's okay. Let's check one of the chips. One of the chips says 3 mega ohms. Okay, that's okay. Then we have a 10 kilo ohms. Then we have a mega ohms. 4 kilo ohms. So I bet you this one isn't working. So we'll mark these, the ones that are too low on the -5 volt rail. Let's start from the left. This is mega ohms. This is mega ohms. It's chipped one, but we'll sort it out later. This is mega ohms. This is mega ohms. I think we only have one, which pulls it down to 5 kilo ohms, which is this one. All right. Mega ohms. Kilo ohms, 10k. It's still a bit low, and it's chipped, so we have to get it out anyway. So we can just keep them chipped like this. It's no problem. The only thing is the combined impedance, which is now in a mega ohms because we didn't connect anything to the minus 5 volt. So let's connect that back again and see if we get all the voltages on the board. So we don't have a UDA chip in, but that's no problem. It's just checking the voltages. So we want to see, do we have all of them? Only no 12 volts. That's a pity. Alright, so we still have a problem on the 12 volt rail. That can be R62. Where is R62? Let me check. I need a board layout. Just a second. Let me grab a board layout. I have an issue 4B board layout, and I want to find R62, so it's probably this one here. On the schematic it says it needs to be a 15 ohms. This is measuring 15 ohms, so that's okay. I don't see any burned components anymore. Could be a D15 diode, one of the thick ones here. Seems okay. Then what else could it be? R59 could be the problem. Let me check. Should be this one here. Let me check. That should be a value of 1.8k. Yes, that's okay. Let me check. I don't see any other problem at the moment. We have R58. R58 is just above the other one. Yeah, this is 1K. Brown, black, red. I was reading it from the wrong side. Alright, 1K, that's alright. So, I think we checked most of the parts. That could be it. So I'm wondering if it is the coil there. It could be the case. We got R60, let's check that as well. It's above the other ones. This one, 22, I think. Oh, 220 ohms. Yeah, that's okay. So I'm suspecting the coil. Maybe it's burnt because we also had a burnt resistor. So could be that too much current has gone through the coil. The resistor that was burnt still said it was 2K2. So it seems like something has burnt and might be the coil. So let's get it out and test it in a known working board to start with, and after that we'll see. you often can't tell if it's burned or not, so we just have to check it. Doesn't need to be a problem, but let's test it in the working board. Right, let's get this known working out. And it's suspecting wrong one in. Just a quick test, and we know if this one is dead or not. Do we have 12 volts? Yes, we do. So that's not a problem as well. Let's solve this one in nicely. We still have a problem on the 12 volt line. Could be there's something on the 12 volt line that is causing the problem. Of course, one of the lower end chips. So that must be it. Should be it. So the coil isn't it. Next thing is we are going to check if the chips on the lower RAM might be causing this. I should have tested that first, of course. And we don't need to worry about the two with the crosses on it anyway, so one of those might be the problem. So let's just test it, you know. And there we have it. We have 12 volts again. So it was just those two chips, or one of them, which was causing the short. That's fixed. We don't have a ULA chip in, so it's not booting at all. So that's working now. Next is getting the ULA chip back in and see if we got anything working now. So I'll just of course get the lower 2 RAM chips out first. Right, it's in. I will get those two out. That's one thing we can do. So the second one and the fourth one need to get out. And then we get to do some testing, and if the voltages stay stable, then we can put in working chips here. And I think we have a working board then, or maybe there's some other problems in upper RAM or the CPU or something else. We have to check that, of course. We'll find out in a second. But this board takes quite a lot of time. It happens. Sometimes you're lucky, sometimes it takes more time. I bet the voltage will stay fine now, and we can test the board with the ULA chip again, and I bet we will see something on screen. It will beep with the diagnostic card software running, but if it doesn't, if we still got odd noises and so, then there is a problem with other parts on the board, like the Z80 CPU, and it wouldn't surprise me because this board did have some damage. In the power circuit, both transistors, the resistor that was burning, has been burning for some time, and 2 lower RAM chips at least, maybe more, we'll see. And that could have any cause, but often it is old capacitors causing these kinds of problems. But sometimes it can be something like a wrong power supply that has been connected. I mean, the 5 volt regulator was replaced as well, So that could have been the problem. All this old tech will keep you busy for some time, as you can see. Right, I think we're about done. Let's check if we can get them out. Yes, there's one. And that's two. Right. You both can go. We still didn't connect the -5 volt back to the remaining chips, and I still need to replace at least this one because I chipped the top off, which is a pity, but it can happen. Let's connect the -5 volt line back and do a quick check, visual check if that's done correctly. It's hardly noticeable, but these pins have been resoldered. Alright, that looks quite nice. Let's do a quick measurement and a checkup, visual check, if nothing has been bridged. Yeah, that's fine. Let's measure if the pins are all connected now. Cool. This one hasn't been connected, so there's only one remaining, and that's a chipped chip, so we have to do that, get it out later on. Alright, but now we'd like to see some results, don't we? So at least the voltages should remain on, and I see something sticking out here. What is that? It's a pin. And another one because we got the 12 volts from these two. Yep. Alright, let's do a check if none of the pads have been bridged or tracks in between. Looks okay. Oh, this is another remaining pin here. Alright. Oh, there's some garbage on the back. Let's clean it up a bit. I don't want any bridges. There's still a lot of garbage there, so we have to clean it up before we can power it on. Alright. Alright. That's a lot better. We'll clean it up later. It's just to make sure that nothing has been bridged. Oh, sorry. Okay. Let's check the voltages, and you can hear it already. It's working. Now let's see if we can get a picture out, and we know already that we don't have a complete picture because the two lower RAM chip are missing. Let's switch over to here. I can see it here, missing some colors. It's almost working, as you can see. So let's get the working chips in there. I just showed you this cabinet here, and I will try to find two matching STC chips. It's a bit of a pity I can't find any. Maybe I can use the ones from this board here. Yeah, we can. Let's do that, because this is my test board. It's not a big deal. Use other ones in there. So we got this one, which is a good match. It's almost the same time period. And then I need to grab two that are slightly different, but not that little worst. Something like that. No, those are too different. Let me see. This one is not the best match. Is this one better? Yeah, I like this one more. So that one and those are glossy. I don't like them. Okay, let me check if I can find a couple on other boards. Just a second. I need to test them obviously, but we'll do it on this board then. I got one here. We'll test that in a moment. That should be enough if those two were the only chips that were not working. But I've got another board with more of them. So let's test if this one is working or not. Let's put it on this on the most left socket. All right. Seems to work, so I think we can use that one. And then we have matching chips, which I like. Visually, oh, I need to find one more because of the chip one, but we'll do it later on. Okay, this is working. It's okay. It's a bit dark on the output there. I don't know why. There's no reason for that. Maybe it's just a connection. Yeah, it's just a connection. So, sorry, what's the connection? All right. This one is working. I just want to know if the board is fixed, and we'll replace the other one as well later on. So now we have a nice set of matching chips. I like that. The production dates are relatively close as well, which is good. Right. So I had warranty to my refurbished boards, because of course these are still original chips. I have new ones, but for the looks and to have the feeling you're using original board, I think it's cool to have the original chips in there. But within the warranty, it's no problem to replace them if needed. All right, let's see. Do we have positive results? That looks a lot better. So, for some reason the output is a bit dark, but it's the connection, I think. Let's see, I'm watching my OBS stream here, and the LEDs are quite bright, as you can see, but it's getting dark again. Why? It's just the output, I don't know. On my display here it's okay, you can see right next to me. So it's only the composite video output that's... Okay, we have an upper problem still, upper end problem, which says I see 19 and 22. There's still two problems here. Where did I leave my marker? It vanished into thin air. 19 and 22. Oh, here it is. So 22 and 19. So those two have to come out. And this one needs to be replaced later on, but just for the looks. Almost there. It's a tough board. You can't lie. It's not the simplest one, but we're getting there. And I think you guys like seeing these boards come back to life, don't you? Let me know in the comments if you like seeing these boards revived, because that's what I do. A lot. So I got plenty of upper end chips. But the STCs are depleting, and I remember like 10 years ago I sold a batch of used lower RAM chips which I removed from old boards that I couldn't repair back then. Nowadays I would be able to repair lots of more boards, as you can see, like this one. But I sold them, those chips, those used chips, because I had new ones back then as well, and yeah, I shouldn't have sold them. I think it was like 80 chips or so, I don't know. But once I find more boards with bad STC chips, I will just grab one and remove all the chips and replace them with new ones, and then use the old ones for these boards, you know. Sometimes I will do that. Alright, don't have much time left before dinner. Right, let's find two other ones. These are frees, these are okies, these are others. Ah, these are... I thought I had plenty of those, but nope. So I need to find a substitute for them as well. I saw some here. Yes, yes, those are exactly the same ones, and these have a V on them from tested, so I can use these ones. And let's also grab one for this position here, which is different. But first let's put in these two, and I doubt, I'm not entirely sure if these are working, so let's do a quick test in this other board. I need something in here, of course. Can be anything, just 4116. Let's put an ITT next to the STCs. Right. And power it on with some picture. It's getting really messy. All the soldering garbage. Alright. So first I will check if these chips are working. It takes a second, of course, because I need to test all of them. I don't have a keyboard, so I have to wait. Sorry. So this is my test board, which is fully socketed, I guess, except for the LM1889. Seems okay. Yeah. Okay, that's okay. That's one. And next. I could just do it once, of course, but this is more safe, you know. I will solder in this one here, flying. There was some plastic I could get it in between, but I don't think I have something in the neighborhood. Ah, I have something here. Roller skates. So why wait if you can just continue soldering, you know? Okay, this one isn't working. It's IC19. Too bad. It's a pity. I will keep this one for in my box of dead chips. I have more, so I can find another one here. So I have some untested chips here. Although there was a V on them, there are plenty more of these TI chips, so we can check other ones as well, but we'll see that later. Okay, this one is working as well. Just one more and then we're done. And we should have a fully working board. Nice, matching chips. Oh, there was a blob on there. I hope it's going okay. Still working, so yeah, this is working as well. Just one more chip to test, and then we're done. So again, I could use new chips, but I like to put in original ones. But this is failing as well, so not a bad chip. Too bad, but we know at least we got enough for now. I will find another substitute later, but for the one in the socket, the other board. But for now, let's let's solder them in completely and do a check test, and I think this will work just fine. And I have to clean up the board completely because it's a terrible mess, but we'll do that later on. Oh, this I think chip is in, no, it's just got short legs. There's some solder in between here. I want to remove that. So most is okay. And I will do the cleaning later on. That's no big deal for now. All right. Phew. Let's see. A lot of dead chips today, but what can you do? So the composite video converter is not working that well, but on the it's again very dark, but it's really converted, because on the display it's okay, and in the cable I put in the capacitor, decoupling capacitor, so that should be fine. Okay, it's testing completely normal. That's bad. It's dark. Maybe it's something with my filters on it. It could be as well. Let me see if we can change it. Yeah, I've got some filters on there, so I bet it's one of the filters. Let me check. It must be the filters. I think it's one of the filters here, so don't worry. Picture output is just perfect. So we got a working board. We got a new 5-volt regulator, which doesn't get hot. We need to put a heatsink on the ULA chip, but it's a Type 7 ULA chip, so that's okay. We could remove the socket from this buffer chip here, but it's not needed, so let's keep it in. But I will remove the one from here, so it looks better overall. The PCF chip is working as well. We'll do more tests, of course. I will check if the tape input is working, if all the keys are working. So I need to finish some tests. But the board is working, so I'm quite happy. I don't have a keyboard here right now. It's on the other side of the room. But for now, this is a working board. We fixed it. Just need some slight cosmetic fixes. But I can ship this to the customer. So let's get back to this one here, and thank you for watching, and I will see you in the next video. So bye.